Greetings everyone. In this tutorial we are going to see that how we can classify epilepsy data using EEG. The data is taken from this paper. You can get this notebook from the GitHub repository. In the GitHub repository you have to go to this YouTube tutorial repository and then you can find all of the previous notebook and this notebook. The data set is taken from this paper, Reliable and Automatic Epilepsy Classification with Affordable Consumer-Grade Electroencephalography in Rural Sub-Saharan Africa. This dataset is basically captured from two different areas of Africa. One is Nigeria and second is Guinea-Bissau. And the accuracy achieved is 85% and 78% in Guinea-Bissau and Nigeria. What we are going to do is we are going to apply a very simple technique. Let me open the notebook in Google Colab and we can see how much accuracy we can obtain using this data. I'm not going to code it. I'm just going to run the existing code and I will explain it line by line what I have done and how you can run this notebook. The first thing is that you have to install the MNE package. This package is basically related to EEG analysis or MEG analysis. So it will take a couple of seconds to connect the Google Colab and then it will take further time to install this package. Okay, dataset is collected using eMotive Epoch Plus with the 128 Hz sampling frequency. There are two different datasets which I have taught earlier. Guinea-Bissau dataset have 97 subject and Nigeria have 112 subject. For the sake of tutorial, we are only dealing with the Guinea-Bissau dataset. So I am using wget command, which actually is a Linux command to download the zip file or any sort of file from the internet. So it will download the file from the Zenodo website and then we will extract the zip file. You can see that on the left panel this file is being downloaded and you can see 7% or 25% the file is being downloaded. After the file is downloaded, we have to unzip that. For that I am using Python package zip file. I can also use Linux unzip command. So let's click on that, run that code and you can see now this zip file has been extracted. Let me analyze the zip file. There are different signal files which are in the format of csv.gz and you can also see that there is one file which is actually this one. We are directly reading this one from the Zenodo website. This is one of the power of pandas library that you don't need to you do not need to download the CSV file. You can direct call it from the website. We can also download the CSV file using wget and then we can read it in pandas. Now I have imported three packages: pandas for the data frame, numpy for the numerical calculation and matplotlib for the plotting. After that I am reading the file from the Zenodo website and I am just printing out the first 5 rows to see how the data look like. You can also get the Nigeria dataset from this link. Let me open the link. You can see that there are Nigeria dataset, EEG Nigeria and the associated CSV file. You can also play with that. So my CSV file has been read and it is being displayed here. We have group is associated with whether the subject has epilepsy or it's a normal subject, what is the eye condition at the time of getting the data, what are the remarks and what are the recorded period for how many seconds the data is being collected and what is the started time. We are only interested with the subject ID and the group. The next thing I have to do is that I need to separate both of the groups, that is epilepsy and subject and control. So I write a pandas query that take the metadf file and select the subject ID. Let me explain it in another way. Start it from here. Take the metadf group column and all the values which have epilepsy in it. So it will get all the rows which have epilepsy and then from all the rows we have multiple columns such as subject ID, group, eye condition, remark, then only select the subject ID. So in this way we got all the subjects which have epilepsy. The same thing we will do with the controls group. First select the control group, all the rows which have control in it, and then get the subject ID column. You can play it with by putting it into two different cells and see what is the output. The next thing, we have to read the CSV file. One way is to first unzip the GZ file and then read the CSV, but in the Panda is so powerful that you can directly read the csv.jz file, but you have to provide an additional parameter, that is compression, and you have to tell that the file is jzip and you need to decompress it. So this line pd.readcsv is basically unzipping and reading the file. I have used list comprehension, which is basically for loop, to iterate all of the files and read them one by one and store it in a list. So my EP subject, which is basically, let me show you what is inside my EP subject. EP subject is basically subject ID. So it says that, okay, take the signal file from here, and what is the subject ID? Subject ID is 1. Put that 1 inside this bracket. This is basically string format. This I is basically first time it's 1, then it's 3 for epilepsy, then it's 4, and then it's forward. So first it's 1. So I is 1. Put that I inside this bracket. So that file becomes signals-1.csv.gz, which is actually this file. So this file is related to epilepsy, and then read this file. Similarly, do this with all of the files and read all of the data of epilepsy in the epilepsy variable. Do the same with the control, and then I am going to display the epilepsy dataset. I am just displaying one subject. So you can see that we have 36 columns, and I have told you maybe that we have only 14 columns in emotive device. Basically there are only 14 channels, so I have to remove the unnecessary channels. I am going to drop the first channel because this is not wanted, and I am going to remove all of the channels after 14 channel required. So I'm starting with 1, which is actually this AF3 channel, and I'm going to till 15th channel, that I'm going to capture 14th channel from the epilepsy dataset and control dataset. And I am also using list comprehension and looping all of the data frame which are stored in a list one by one and selecting 1 to 15 column. The next thing I have to do is to convert these CSV files into MNE object. I have already shown you this function in one of previous tutorial in this series, but let me explain it again. First, I am going to create an info variable, which is MNE info object. It takes few parameters. One is the name of the columns, which I am taking here, sub.column. And the next variable, what is the type of this column? We are dealing with EEG. If we are dealing with MEG, then we have to tell that this is MEG. And if we are dealing with EOG, we have to tell that we are dealing with EOG channel. And then we multiply with the number of columns we have. As we have 14 EEG channel, so this will become a list which have 14 times EEG. After that, we define the sampling frequency, which is 128 Hz. This created the MNE info object. The next thing, we have to set the montage. Montage is basically how your electrodes are placed on your head. If you check the documentation of the emotive epoch, you may know that the configuration for the electrode attachment with this scalp is basically standard 1020. After that, we use the raw array from MNE and convert the information, which is info, and the data, which is actually in this sub variable and is a array maybe, and convert it into MNE raw array. After that, we need to set the EEG references. EEG reference is basically a way to normalize the EEG data. It actually take all of the EEG data and take their average and then normalize the rest, or normalize the channel with the average of all the channels. Then we are going to filter the data. After the filtering, I'm going to make fixed length epochs. Epochs are basically segment. Let's say if we have collected the data for the 10 second, we can create epochs of 2 second or 1 second or 3 second, whatever we required. I have created epoch of 5 second with the overlapping of 1 second. Once we got the epoch, we can automatically drop the bad epochs from them, which MNE can do it, and then we return the epochs. Once we have defined this function, we will call this function using list comprehension on each of the data frame which are stored in a list epilepsy and a list control, and we convert this data frame into MNE object. Once we convert the data frame into MNE object, it's still in list form. We need to convert this into MNE. And now using MNE.concatenate epochs, we are going to concatenate all of the epochs in our list to MNE object. Our MNE process is completed almost till this point. The next point is how we can create labels and groups. I have explained multiple times that why we need groups and how we can create labels. Let me explain first how labels are created. Let's say for the epilepsy, I am going to say that the label is 0, and for the control, I am going to say that label is 1. I am using list comprehension again, and I am going to loop all of the epochs in the epilepsy variable, and then I am going to take the length. Let's say my first subject, which is in the list, has 200 epochs. Then I am going to multiply it with the list having 0. Now I have a list with 200 0. And let's say second subject has 150 epochs. So my list has 200 zeros and 150 another zeros. And let's say my third subject has 100 zeros. Now I have 200 plus 100 plus 50. 200 plus 100, 150 plus 100 zeros. The same with the control. So actually I am assigning a label with each of the epoch. Once these labels are created, the next step I have to do is to create the groups. Actually the groups are subject number. I assign a unique subject ID or subject number to every subject. Let's say the first subject, I assign it, first subject has, let's say 100 epochs. So I assign 0 because to the first subject, all of the 100 epochs of first subject. And the second subject, I assign 1 to all of the epochs of second subject. And for third, I assign 2 for all of the epochs of third subject. Why I am not assigning 3 to the third subject? Because indexing in Python start from 0, not from 1. So for first subject it will be 0, for second subject it will be 1, for third subject it will be 2, and so on. So actually I am creating a list of list here. The first list in list of list is 0, the second list in list of list is 1, the third list in list of list is 2. So hope it is clear. If it's not clear, I would recommend you to watch the previous tutorial where we have done this maybe in a different way. After the list has been created, I'm going to concatenate it, which are actually converting the list of list into a NumPy array. This is the number of epochs, which are actually 3995 in the epilepsy group and 3461 in the control group. Similarly with the labels, the groups and the number of epochs should be the same. Now we are going to combine the data. I'm combining the epochs using mne.concatenate epochs because this is an mne object, not a numpy array. So I have to use mne.concatenate epoch. To concatenate the epilepsy group and the control group, I am using numpy concatenate because these are numpy objects or numpy array. The same thing with the label. Now I have 7,456 total epochs and 7,456 labels and groups. Now we need to extract the features from this data. To create the features from this data, I am going to use EEG power band. Actually, I am using power spectral density, which tells us the frequency content of signal or the distribution of signal over frequency. It converts the signal into frequency domain, and for each frequency, it tells us what is the power of the signal at that time, whether the signal is strong or weak at that point, basically. There are different ways to convert your time series signal into frequency domain, such as fast Fourier transform, Welch method. Fast Fourier transform actually take whole of your time series data and convert it into frequency at once, whereas Welch method split your time series data into windows and calculate the frequency for each window. So I am converting this data into different frequency band. In EEG, basically there are different frequency bands such as delta, theta, alpha, beta and gamma. Actually, you may not aware of this sigma band because it's not very common. Actually, delta, theta, alpha, beta and gamma are more common. You can even remove that, and you can see that the alpha band is basically around 19 to 15. You can remove the sigma band, that is not necessary. You can take whatever frequency you want. Next, we are going to use PST Welch from MNA time frequency, and we are going to take the minimum frequency, which is 0.5, and maximum frequency, which is 45, and calculate the PSTs and frequencies. Next, we are going to normalize these frequencies by taking the sum and dividing each PST by the sum of all the PSTs. After that, we are going to separate each of the band. For that, I am going to loop the bands, and I am going to select frequencies based on the minimum values and the maximum values. And based on the frequencies, I am going to select the PST. So let's say our frequency is 0.5 minimum and it's between 0.5 and 4.5. So I am going to select the frequency range here, and then I am going to pass this information to the PSTs. Actually, these are the indexes we are going to pass this PSTs, and it will get all the PSTs with the frequency between 0.5 to 4.5. Then we are going to take the average of these. Instead of average, you can take standard deviation, variance, power, whatever you want. Then we are going to append these PSTs into a X list. After that, I am going to concatenate these lists into which will make into a numpy array into a single feature vector. This is how we are going to extract our feature, which is actually a power band. The next thing I am going to is to import random forest classifier and cross Welch score. Random forest classifier is basically for random forest classifier is basically for classification, and cross Welch score is basically for 5-fold cross validation. After that, I am going to extract these features from each of the epoch, and for that I am going to use a for loop which will iterate each of the epoch and calculate the feature and then append that information into a features list which we have created. Once our feature extraction process is complete, we convert the list to array, and now we are going to use the random forest classifier and cross Welch score to calculate the 5-fold accuracy. The cross Welch score required classifier, features, label, groups and CV. Sieve is basically how many split you want. We want 5 split, 5-fold cross validation. So I have passed 5 here. You can improve the, now we will see how we can further improve the results. You can try different classifier instead of random forest classifier. You can try SVM. You can try linear logistic regression. You can also tune the parameter of this classifier using grid search technique, which is, you can also try a random grid search technique if it's taking too long time. And you can also try feature elimination. There are different ways to do feature elimination. You can, if you are doing unsupervised, if you are going unsupervised way, you can use principal component analysis to reduce the dimension of feature, and it will give you important features, and then you can classify those features. You can also try recursive feature elimination, which will recursively reduce the features and see if the performance increased or decreased. So there are different ways to enhance the performance, which is actually around 69% right now. And one thing you should do is that I have shown you the Guinea-Bissau dataset. You should do the same with the Nigeria dataset and see how much accuracy you achieve. You can also try to get the F1 score or the precision or recall and see how much score you have gone. So basically this tutorial regarding how we can deal with the epilepsy data, and I hope you will like that tutorial. Thank you.